Welcome back to chapter number 3, part number 2, where we're learning how to name compounds. In part 1, we learned everything there was to learn about naming ionic compounds. Hopefully you're able to get a little bit of practice and naming these compounds to where it just becomes second nature to us. So what we're going to do now is we're going to move away from ionic compounds into molecular compounds. Molecular compounds are a little bit more difficult to name. Usually these are composed with two or more nonmetals. We're going to focus on just the two nonmetals. We're really not going to worry about more than two. So here's how we name these. Let's do nitrogen, a compound with NCl3. Let's do NCl3. Now, NCl3 is interesting. And NCl3, right? So there's one nitrogen, that's N, and then there's three chlorines. So let's think about, these are two nonmetals, right? Nitrogen is a gas, chlorine is a gas, so these are two nonmetals. So let's think about naming these. We said there's one nitrogen, so the prefix for one is usually mono, and so it would be mononitrogen. And then there's three chlorines, so it would be tri, and we name the second element the same way we do with the ionic compound. So it'd be trichloride. So mononitrogen trichloride. Now, in the case of this, mono is usually omitted from the first element named. So now we just have nitrogen trichloride. Now, writing a molecular formula from the name of a molecular compound is really easy because you know how many there are and you know what they are, right? So if you see nitrogen trichloride, you know there's one nitrogen and there's three chlorines. And so it'd be NCl3. Let's look at another example, carbon monoxide, right? So now notice I didn't say monocarbon monoxide, monooxide, but I said carbon monoxide, right? So there's one carbon and mono meaning one, there's one oxygen. So that's C and then O, right? So molecular compounds, we just have to realize, oh wait, there's two nonmetals. Okay, this is how I'm going to name it. And I have to tell you how many atoms are in the molecule. So there's one more group of compounds that we're going to name, and those are acids. Acids are molecular compounds that usually release hydrogen into the solution. We're going to talk about acids in reaction with bases later in chapter 4. That's about as much as we're going to get into with acids in this class. In Gen Chem 2, you cover acids in a little bit more detail. There's two types of acids. There's binary acids, and then there's oxyacids. Oxyacids are just those acids that contain oxygen. Binary acids are anything that really doesn't contain oxygen, and that usually contains just two elements. Acids, the way we can tell acids, again, the way we know an ionic compound from any other compound is it is a metal and a non-metal, right? So if you see a metal as the first element, there should be bells in our head going, ooh, ionic, ionic, ionic compound. And then we just have to determine how to then name that ionic compound. If we see two non-metals, then we need to say, oh, this is probably a molecular compound. There is one exception, and here's the exception. When you see a hydrogen, usually as the first atom in a molecule, if you see a hydrogen, the bells again should go off in your head saying, oh, acid. This is an acid. I need to remember how to name acids. So let's talk about binary acids. Again, remember, binary acids are composed of a hydrogen and a non-metal. So let's look at HCl is the metal that's in here. We'll be able to do this type of experiment in the lab where we're looking at metals and acid, and we're actually going to talk about the type of reaction that we're showing. So let's say we're talking about HCl. So we start naming acids, binary acids, two things with a hydrogen at the beginning, with hydro. Okay, hydro, and then chlorine. We drop the INE and we add the IC, so it's hydrochloric, and then you put an acid. This is how you name binary acids with an H at the beginning. So let's say we do HF. right? So F is fluorine. So HF is hydrofluoric acid. Let's do H2S, right? So H2S, it doesn't matter how many H's there are, we name it the same. So H2S is hydrosulfic acid. Okay, so all binary acids are composed of a hydrogen and a nonmetal. That's how we do that. Now let's talk about oxy acids. And here comes table 3.4 again, right? And we said we have to know table 3.4 because we'll see them in ionic compounds and we'll see them again in acids. And so for oxy anions ending in 8, so let's look at the nitrates. So nitrate is NO3, nitrite is NO2. So nitrate ends in an ATE. So if we had a chemical formula, HNO3, we just change the ATE into an IC. We don't put hydro in front of it. So if you see an acid with an oxygen, we do not put hydro in front of it. In this case, it would be nitric acid. Since it's a nitrate, ATE, we change the ATE into the IT, or into the IC, excuse me, and it'd be nitric acid. So HNO3 is nitric acid. HNO2, because it ends in an ITE, we change that ITE to OUS, and it is now nitrous acid. It's going to take, again, some getting used to and some constant naming. And so do the homework. I'm going to, like I said, I'm going to give some extra naming problems, some extra math practice. Just do that. And as you're going through it, try to do it without looking at my notes or looking at the PowerPoint or looking at your notes. Just try to set in front of your homework assignment and say, okay, what are these names? And then just try to name. And as you name it, see how many you get right. And then if you have any questions, come back and ask me, come back and ask your classmates. And so here in your book, there's a very nice nomenclature flow chart. We're not going to talk about organic compounds and naming them, just because you'll get that in organic chemistry with methane, ethane, propane, different numbers of carbons. And so that's for a later class. So we're going to look at the inorganic nomenclature flowchart. And so what you see is you have the ionic on the left, the molecular in the middle, and the acids on the right. Again, as you are naming these, start out maybe naming with this flowchart in front of you. And then as you get more comfortable, go and put the flowchart away and see what you've learned. You would be, I think you guys will be surprised at how much you actually know after doing a little bit of practice. I have confidence in you guys. So remember, chemistry is the only thing that says, the only science that says you matter. So nomenclature. Well, what can we do with formulas, right? Because we're talking about formulas. What can we do? Why do we care about formulas? Well, one of the things that we need to do, because we talked about moles at the end of chapter 2, we need to know the mass of a compound, right? Of a molecule. Because if let's say we were saying, you have 2 grams of water, how many moles of water do you have? H2O do you have, right? We need to know the mass of water. And so let's go ahead and we're going to look at a couple, we're going to look at a couple examples on how to calculate formula mass. Formula mass is pretty easy to calculate. And so what we're going to do is I'm just going to walk you through it to show you how we do it. And then once we have the formula mass, we can then plug that into an equation calculating the number of moles, just like we would an individual element. So let's go ahead and look at a couple examples. So we're going to look at ammonium acetate first. So ammonium acetate is this. Page 4. So this is ammonium acetate. Now, if we were to go to table 3.4, what we're going to see is ammonium is on there, or ammonium. Yeah, ammonium is on there, and so is acetate. We can make an ionic compound with two different things from that table 3.4, right? Because NH4 has a +1 charge, and acetate C2H3O2 has a -1 charge. So we can put those two things together to neutralize the charge. And so here's how we calculate formula mass, formula weight, molecular weight of a molecule or of a compound. So what we do is we look at each individual atom in this compound. So let's start with nitrogen, right? So we have nitrogen. If we go to the periodic table, we see the atomic mass of nitrogen is 14.1.01 grams per mole. Let's go to hydrogen. Hydrogen is 1.01 grams per mole. But what do you think we need to do in this equation? What do you see with hydrogen that's different than nitrogen? That's exactly right. Nitrogen only has 1, whereas hydrogen has 7. So what we need to do is we're going to multiply this by 7. And then we get carbon. There's 2 of them. That's 12.01 grams per mole. And then we have oxygen. There's 2 of those. That's 16.00 grams per mole. Okay? And so then what we can do is say for nitrogen, it's 14.01. For hydrogen, 7.07. For carbon, 24.02. And for oxygen, it's going to be 32. And so all we do is then we just add all those together. And the formula weight of a molecule is always in grams per mole. And what we see is 77.10 grams per mole. Now, I want you guys to calculate this, and I want you to try this. And I want to see, and I'll just show you one of maybe the things that we have to consider when we do things like this. Let's say we're going to do magnesium oxide or magnesium hydroxide. So we have magnesium. Magnesium has a +2 charge. Okay? And now we have hydroxide. Hydroxide has a -1 charge according to the table 3.4. So how many hydroxides do we need to neutralize that charge on the magnesium? That's exactly right. We need 2 of them. So what we're going to do is we're going to put a 2 right there. So there's magnesium hydroxide, or magnesium hydroxide. So now I want you guys to calculate the formula mass, or the formula weight of magnesium hydroxide. And what we have to consider whenever we do things like this are these little subscripts. This guy right here. And so if you see a subscript outside a polyatomic ion, right, like HO, we now have to multiply hydrogen by 2 and oxygen by 2. And we leave the magnesium alone, right? Because there's no 2 or 3 or 4 in the magnesium. So I want you guys to go ahead and calculate magnesium hydroxide. And I will, you go ahead and pause the video to do that. And I'm going to write up the answer right now. The answer, see if I can, yep, got it. Was 60.35 grams per mole. Okay, right, so we can use these things, we can use these molecular formulas to calculate molecular weights. So then if I were to say, well, how many atoms are in 15 grams of magnesium hydroxide, we would be able to calculate that. What else can we do with molecular formulas? And I'm going to leave up the ammonium acetate so that we can look at it again, at least with the acetate. What we can do, and this will be the last thing on part number 2. Yeah, on part number 2 is mass percentages. right? Mass percent is the element's percentage of the compound's total mass. And so what we have is, let's say, the mass percent of chlorine in CCl2F2, right? Carbon dichloro difluoro, or dichloro difluorocarbon. What percentage of that molecule is chlorine? Okay, and so the way we calculate that is you take the mass of the element divided by the total mass of the compound times 100% to turn it into a percentage. And so what we have is 2 times the molar mass of chlorine divided by the molar mass of CCl2F2 times 100 would give us the mass percent of chlorine. That's great, but what can we do with those mass percentages, right? Because I might ask you on a test, well, what's the mass percent of this thing in this compound, right? And so I would give you this equation. You would say, okay, I have to remember, okay, that's how I do it. But what can we do with mass percentages? Based on mass percentages, we can do a lot of things. And so we're going to really go over the math in part number 3. But one of the things that we can do is we can make chemical formulas from them. And so one of the most common ways that we use mass percentages is I give you a mass percentage and I say, hey, what's the empirical formula? Remember, empirical formulas are those simplest where it just shows you the atoms and it doesn't actually tell you how many are in there. And then I'll show you then how to calculate the molar ratio, the actual molar formula as opposed to the empirical formula. And so one of the things that we're going to do is we're going to cover how to use determining chemical formulas using mass percents, using combustion analysis, right? Where we take a sample, we burn it to figure out what is going on. And then the last thing that we're going to do in part number 3 of chapter 3 is we're going to learn to balance equations. I know we had to come here sometime, and now here it is. Hopefully you guys enjoyed part 2. So we finished up all of the naming. If you have any questions, I'm going to start using regular names as opposed to just giving you the letters. And again, we're going to start using names, writing molecular formulas, again, just to practice figuring out how to name and how to write formulas. If you guys have any questions, again, please feel free to ask me.